Hello, welcome to this session. We're going to talk about mainframe workloads, fast track to agility. Mainframes typically host core business data and processes. These are very important for large businesses and organizations, but they're often composed of all tightly coupled and large monoliths, which are difficult to change. To stay competitive, customers have to quickly transform their mainframe workloads for agility. While doing so, they have to minimize the risk, reduce cost, and preserve resiliency. The first thing that comes to mind could be a rip and replace approach. That means a large-scale manual rewrite to cloud native. But this can be expensive, risky, and very slow. There must be a better way to get to agility. So today, I will describe key characteristics that bring agility to mainframe workloads. Then, I will detail the approach that quickly and incrementally transform mainframe monoliths into agile AWS services. Before we do that together, let me introduce myself. My name is Phil Devanance, and I'm a principal solution architect focusing on mainframe modernizations. Customers modernize mainframes with AWS because of three main reasons. First, cost reduction. Customers have seen between 60 and 90% cost savings when migrating mainframe workloads to AWS. The second reason is agility. It is actually the main reason why organizations are moving to the cloud. Agility is the ability of a business to quickly and inexpensively respond to change. And we'll describe the many dimensions where AWS Cloud brings agility to mainframe workloads. The third reason is risk mitigation. Customers want to avoid the risk of mainframe specialists retiring. They want to avoid the risk of very slow mainframe changes. They want to avoid the risk of archaic technology. So now, let's dive into how to bring agility to mainframe workloads. For this discussion, we focus on application and infrastructure agility. In other words, how we can change functionality, configuration, or resources quickly and inexpensively. We could look at the key issues that make mainframe workloads rigid and slow to evolve. But we can also look at it from the opposite angle. What are the key characteristics that mainframe workloads require to increase their agility? I've listed here the list of 12 attributes needed by mainframe workloads. First, agile development with continuous integration, continuous delivery, or CI/CD. That includes DevOps best practices. This attribute is needed to go away from mainframe waterfall development cycles. On the mainframe, it can take many months to deliver releases. Number two is integrated development environment, or IDE. This is for developers to be efficient with features like smart editing, debugging, and instant compilation. It differs from mainframe green screens where you have to use terminal emulation, function keys, datasets, and jobs to develop code. Number three is knowledge-based development. This refers to using analyzer tools to understand large application portfolios with possibly millions of lines of code. It's necessary because on the mainframe, code can be very old and knowledge is lost over time. Number four is service-enabled and modular applications. Mainframe programs are usually tightly coupled and intertwined. This makes them difficult to change and evolve. Having them modular and exposed as services introduces flexibility and reuse. Number five is elasticity with horizontal scalability. This avoids sizing for peak workload, few physical machines. It removes vertical scalability limitations and bottlenecks. It also allows paying only for the required capacity based on the current business needs. Number six is on-demand, immutable, disposable server. Basically, that means servers are available in minutes, in any quantity, and they can be disposed or replaced entirely. Number seven is choice of compute, data store, and language. This is important to select the infrastructure with the right quality of service for a specific workload. In other words, the right tool for the right job without vendor locking. Number eight is broad data store access. By avoiding abacitic encoding or legacy datasets, data can be quickly reused and new use cases such as analytics, new channels, and innovation. Number nine is pervasive automation. This increases speed and agility for application development, resource provisioning, or system management, for example, using infrastructure as code. Number 10 is managed and fully managed services. They are easier to use. They minimize the operational complexity, and they allow focusing on application business value rather than on the infrastructure. Number 11 is consumption-based pricing. It allows aligning infrastructure costs with business activity. And more importantly, it provides a low cost of entry for experiments that facilitates innovation. Last but not least, number 12, an innovation platform. Such platform allows building nearly anything you can imagine based on a wide variety of building blocks. It requires a very large set of infrastructure services readily available at your fingertips. Looking at this list of 12 attributes, you cannot get all these on a mainframe. But the good news is you can get all these attributes in the short term with AWS. Before we describe how to get to agility, let's highlight some of the tenets we have. First, we want to maximize speed to value. That means our approach achieves tangible agility benefits quickly. And we do it with speed using mature and automated tools. Second, mainframe modernization is complex, so it's very important to minimize business and technical risks. We do this with evolutionary transitions and by decomposing workloads and using proven patterns. We also use a very hands-on pragmatic approach. We prove technical options as early as possible. Now, let's see what the approach looks like. This is the overview of how we fast-track mainframe workloads towards agility. It's an evolution from the mainframe to agile services. It follows the tenets we just described. It starts from the left-hand side. You can see the mainframe monolith. It has tightly coupled programs calling one another. The first phase is a short-term migration and modernization. In this phase, the mainframe workload is transformed into macroservices. Macroservices are coarse-grained business services. You can see business functions are exposed as services using application programming interfaces or APIs. Macroservices use these APIs to invoke one another. The second phase is an optimization of some services into microservices. But in this phase, only some services, not all services, are optimized into microservices. We only extract microservices when and where it makes sense. Some may ask, why do we migrate to macroservices first? The primary reason is because the macroservices possess the 12 agility attributes that are needed by mainframe workloads. That means they provide more business value in the short term. The second reason is because we create macroservices using tools. This provides speed and minimizes risks. The third reason is macroservices ease the transition to microservices because they benefit from modernized application and infrastructure stacks. The fourth reason is macroservices enable new use cases and innovation sooner. Some may ask, why not go directly to microservices? And there are numerous reasons for that. The important ones are that microservices are not suitable for all workloads. Microservices add complexity, and microservices require manual reengineering, which is risky and expensive upfront. Overall, this approach provides the 12 agility attributes in the short term with macroservices, and it also facilitates the transition to microservices when appropriate. Now, we're going to detail the various aspects of this approach. Something we need to be clear about is the data aspect. Data is one of the reasons why we transform the mainframe monolith to macroservices first, and then consider microservices. And there is sometimes some confusion about microservices. Having an API is necessary, but it's not enough. A microservice needs its own database. Let's look at the evolutionary approach focusing on data now. During the first migration phase, the mainframe workload legacy data store is migrated to a relational database. For example, it can be an index file to a relational database migration. Once migrated, the database is shared by the macroservices. This shared database gives us many advantages. It is fully supported by the tools for quick and reliable migration. It keeps the data in normalization and structure, minimizing application risks. It preserves the data integrity and strict consistency and high-seed transactions. Then, during the optimization phase, we create microservices. A microservice is an independent deployable service. It owns its own data for information hiding. That means a microservice totally encapsulates its data with one database per service. Database here means a logically isolated schema, not a database engine which could host multiple schemas. During this optimization phase, data is extracted from the shared database into one database per service. This is a complex activity and there is a lot of manual reengineering work that's involved. So we only want to do this data extraction when and where it makes sense. Overall, this approach accelerates the modernization and reduces the risks with a shared database first. Then it allows extracting one database per service only when suitable. We looked previously at the evolution from services and data perspective. This evolution is not just a migration, but it's actually a modernization on many dimensions. You can see this table highlights some of the technical changes that happen in different areas, such as infrastructure, application, development, system management, cost optimization, and innovation. And it shows the changes when moving from the mainframe to the cloud in the short term, and then changes when optimizing on the cloud. Let's look at one example on the infrastructure side. On the mainframe, there is a physical machine with finite resources. When moving to the cloud in the short term, the mainframe workload can be deployed on elastic compute or containers. That means we can adjust dynamically the number of servers or containers which process the load. It also means we can scale horizontally for very large workload and only pay for what is being used. Then, we can optimize further by leveraging serverless capabilities, removing the administrative overhead of managing servers. I'll let you review some of the other areas by yourself, but you can see this evolution is a comprehensive modernization. Now, we're going to detail the short-term migration phase from the mainframe to AWS. A mainframe, and especially large mainframes, typically run multiple workloads in parallel. A workload is a set of programs, middleware, data store, and resources that execute a cohesive set of business functions. It is often supported by one data store and one transaction monitor. We usually don't define a workload more granular than a data store or a schema because we want to avoid losing data relationships and integrity during migration. Each mainframe workload is migrated separately. That means each workload ends up having its dedicated resources for compute and data store on the AWS side. We see on this diagram that some workloads end up using Amazon EC2 instances. Other workloads use containers or serverless Lambda functions. At a high level, workloads are migrated one after the other. We prioritize workloads migration based on business criticality, technical complexity, integration points, and business value. And over time, we strangle the mainframe workload by workload. Let's look at the migration for one mainframe workload specifically. To minimize the risks and accelerate the speed of the migration, we use proven tools, which provide emulation and automated refactoring capabilities. These capabilities are essential to reuse and modernize mainframe assets quickly. These tools facilitate following cloud best practices for availability, scalability, and security. During this migration, the application code is ported or converted, then recompiled for deployment on AWS. Data is also converted and migrated, usually to a relational database. If possible, there should be no manual code rewrite to avoid human errors and risks. Depending on the migration toolset that's used, there can be more or less emulation involved, or more or less automated refactoring happening. In many cases, the toolset provides emulation or compatibility runtimes. Sometimes they're packaged in libraries. These minimize application changes during the modernization. For example, vSAM index files are modernized to a relational database this way. What's important is that this tool-based migration is a modernization in many ways, and it brings the 12 agility attributes that we're looking for. For example, you can see the CI/CD pipeline for agile development. You can also see the horizontal scalability for elasticity. If you want to learn more details about such migration and tools, we have articles and videos available online, and you will find links about them at the end of this presentation. This tool-based migration allows creating macroservices. Let's focus on macroservices for a moment. Macroservices are coarse-grained services, which typically share a central database. They are invoked using APIs. But how do they get created? Well, they are created using the same migration toolset. And you can see here 3 different ways. The first way is via direct API enablement. In this case, some programs are selected and directly exposed as services using REST or SOAP APIs. To create these, some interface operations and fields are defined and then mapped to programs and parameters. The service interface is enabled and ready to be invoked over the network by client applications. The second way we can create microservices is using toolsets which separate the front-end logic from the back-end logic. When doing so, toolsets actually automatically create back-end APIs that are ready to be invoked by the front-end. And of course, these back-end APIs can also be invoked over the network by client applications. The third way we can create macroservices is by identifying independent programs or by performing pinpoint tool-based code refactoring. It's also called code slicing. For example, some toolsets can extract specific business logic in its own module or package and expose it via an API. Once these macroservices are created, they can be quickly invoked and reused by other applications or by innovations. All right, the migration phase is not only a quick migration, but also a monolithization in many areas. Let's look at the resulting architecture on AWS. This is what it looks like in the short term. You can see on the left-hand side the CI/CD pipeline, which follows DevOps best practices. It includes on-demand development environments, source control, and pipelines for automated build, test, and deployment. You notice in the center the macroservices which are deployed on elastic compute and manage relational databases. You can see on the right-hand side that innovations can immediately access the macroservices. They can access the macroservices business functions directly or the data directly. At the bottom, there are key components for the quality of service. Mainframe workloads are often business critical, so we make sure we meet or exceed non-functional requirements for high security, high availability, high scalability, and strong system management. That's where AWS has unique experience and operational excellence for executing enterprise workloads. Now, here comes the best part about this architecture. The best part of this architecture is that it provides the 12 agility attributes needed by mainframe workloads. It provides these agility gains for all the business functions that are part of a workload migrated to AWS. And even better, it provides this business value in the short term using a tool-based approach that minimizes risks. This is the reason why we migrate mainframe workloads to macroservices first and then optimize to microservices where appropriate later. Let's review these 12 agility attributes. Number 1, the agile development is provided by the CI/CD pipeline that we mentioned before. It can use AWS code services. For attributes 2 and 3, the IDE and the knowledge-based analyzer tool are integrated within on-demand development environments. They can rely on Amazon EC2 instances. For attribute number 4, applications are service-enabled with microservices and APIs. For attributes 5 and 6, compute is available on demand and is elastic using autoscaling. For number 7, AWS provides a wide selection of compute resources that meets the variety of mainframe workloads requirements. Also, a large choice of managed databases is available. For number 8, AWS databases can be broadly accessed over the network with convenient character encoding. For attributes number 9 and 10, many AWS automation and managed services improve speed and reduce complexity. Regarding attribute 11, AWS offers pay-as-you-go pricing. For number 12, The wide selection of AWS services available in minutes foster innovation. You can notice here the importance of having a large selection available for compute, databases, managed services, etc. It provides more agility gains, and that is unique to AWS. So in a nutshell, this AWS microservices architecture provides plenty of agility gains for mainframe workloads, and that is obtained with a shorter migration using tools. Now that we have migrated and modernized mainframe workloads to AWS using macroservices, we can engage into the second phase for optimization and innovation. This optimization is facilitated by the breadth of services and features readily available in AWS. There are over 175 fully featured services in AWS Cloud, so we can optimize the migrated workload for more agility in many different dimensions. For example, we can create more granular services towards microservices, or we can introduce more automation with pipelines and infrastructure as code. Or we can reduce operational complexity and increase speed with managed and serverless services. There is another great benefit of creating microservices on AWS in the short term. We can quickly integrate them with the rest of the AWS services for innovation. And this applies to the complete mainframe functions and data which were migrated onto AWS. For example, we can quickly introduce predictive analytics or AI/ML. We can also enable new mobile or voice interfaces. Or we can introduce new use cases based on serverless and container services. Really, once the mainframe workload is migrated to AWS, we unleash its application and data potential with agility. In the overall evolution to agile services, the mainframe monolith is migrated to AWS microservices first, and then there is a transition to microservices where appropriate. Now, let's clarify what is a microservice. A microservice is an independent deployable service. That means it can be developed, tested, deployed, and scaled independently from other services. It's loosely coupled with other services. It's modeled around a business capability. That allows grouping strongly related functions and aligning them with business outcomes. A microservice owns its own data. This is so that each microservice is independent and decoupled from other services. It is also for information hiding, which prevents unintended coupling. So if you see a database shared across services, these are not microservices yet. There are many benefits around using microservices, for example, autonomy, technology choices, scalability options, reduced time to market, smaller blast radius. But there are also drawbacks and challenges with microservices. For example, managing distributed transactions and losing ACID properties are difficult. Dealing with the eventual consistency may not be acceptable. Network latency and failures can make things unpredictable. Microservices operational complexity can increase exponentially with the proliferation of functions, databases, and interfaces. As James Lewis says, microservices buy you options. That means there is a cost for microservices, and you have to evaluate whether the options are worth the cost. That's the reason why microservices should not be the default target. Actually, coarse-grained agile microservices often meet the customer business needs really well. We should incrementally create microservices only when and where it makes sense, with a specific goal and scope for each. Let's assume we have a good reason to create a microservice. For example, if we know a specific business function needs extreme scalability with a different data store type. In this case, we'll have to extract both programs and data in order to create a proper microservice. Fortunately, extracting a microservice from a modern stack on AWS is much easier than extracting a microservice from a legacy mainframe monolith. On the program side, we first have to identify the granularity, the business functions, and programs grouping. We should look at the scope of transactions to avoid the challenges of distributed transactions. We can use domain-driven design to help modeling the business domain and dividing it into bounded contexts and aggregates. Then, we can map these to individual microservices. I suggest you look into the event storming approach. It's a fast way to model a domain following domain-driven design. From a tool perspective, analyzer, and refactoring tools facilitate the actual program extraction and packaging. On the data side, data extraction is a really important part of creating a microservice. And when we say data extraction, we really mean separating database schemas. A lot of the complexity of breaking complex systems lies in the data. There are patterns and techniques to split a database. For example, we can use database views, wrappers, replicas, or synchronization. Along with data separation, we have to take care of data consistency and transactionality. That can require implementing compensation patterns such as sagas or try, confirm, cancel, TCC. Sometimes a pinpoint manual rewrite of a business function may be more effective than program extraction. When that is the case, the small functions rewrite should take a few days or few weeks. If it takes months for rewriting a service, it likely means the manual rewrite is not the right approach. Overall, extracting microservices is an incremental effort for both program and data extraction. It's done in small steps to learn from the process and adjust where needed. Now that we have seen the overall approach from the mainframe monolith to microservices on AWS and microservices were suitable, I would like to highlight how fast we get to agility using this approach. On this graphic, you can see horizontally the time it takes to modernize an average mainframe workload. And you can see vertically the agility gains we get from this modernization. The green curve shows the agility growing with the microservices approach. You notice agility grows very fast around the first year. That is because the 12 agility attributes apply to the complete mainframe workload. It's not just a few business functions being modernized, but the many business domains and functions composing a mainframe workload are transformed into agile macroservices on AWS. Then, agility keeps growing steadily while we extract microservices incrementally. As a comparison, the gray curve shows the agility when manually rewriting microservices straight from a mainframe. You can see how slower it gains agility. The same applies to manual reengineering or reinvention approach. The main reason is because each new microservice rewritten from the mainframe has a small functional scope. Consequently, the agility gains only apply to this small scope of business functions. And because microservices are created incrementally and manually, it takes a lot of time to accumulate these small agility gains. On top of this, over time, it gets more and more difficult and risky to rewrite the more complex mainframe transactions. That slows down the agility gains even further. A manual rewrite or reengineering delays the agility benefits when modernizing to AWS Cloud. In summary, the microservices then microservices approach with AWS accelerates agility for a large scope of business services. This is a fast track to agility for a mainframe workload. If you want to learn more about this topic, I suggest the following content. Some articles are about agility and migration for mainframe workloads. There is also a link to customer stories and tools. I recommend the excellent book from Sam Newman, Monolith to Microservices. You will notice links to tools which illustrate how to extract microservices and how to create a DevOps pipeline on AWS for mainframe workloads. Finally, you'll see a link to the event storming approach which I mentioned earlier on. You will find here some more resources available to you. Some resources are about cloud migration in general. You can also notice the Migration Immersion Day. This is a workshop available to customers and partners. We have actually added mainframe content and labs into Migration Immersion Day, so feel free to request it if you would like to learn and if you would like to do hands-on around mainframe migration. Finally, I would like to highlight that it's never been a better time to modernize mainframe workloads. First, cost savings with AWS are substantial. Second, AWS Cloud provides unique quality of service and resiliency. Third, there are tremendous agility gains with AWS, both in the short term and the long term. So feel free to engage us for your mainframe initiatives. We'll be glad to help. Thank you for joining. Stay safe and have a great day.